I guess just to make everyone aware of the upcoming due dates to start off. Okay, so the upcoming due dates, proportions and linear equations, what it pretty much amounts to, that homework is due tonight. I noticed a good bit of people already went ahead and got started with it. So again, it's not a crazy homework, but there's a few problems to it. Definitely don't want, I'd recommend you don't start it at 8 o'clock tonight, but there's not too much complexity in this homework. If you're familiar with high school basic algebra, that should be fine. And the corresponding quiz is due tomorrow. And I also assigned a workbook assignment. This could all be summarized in that email I sent out with the 3 due dates for the 3 upcoming assignments. And besides for that, there's no assignments until next week. So 3 assignments, homework tonight, quiz tomorrow, workbook Friday. Are there any questions about anything before we get started? If not, let's go ahead and look at the new section on measures of central tendency. So this will be a very calculator heavy section. So if you have your calculator nearby or need to pull out, go ahead and do so. We will be utilizing the TI-83, 84, whichever one you have, quite a bit. But first, let's define what a measure of central tendency is, the namesake of the section. So a measure of central tendency, well, you might not have heard it called this before, but as the name implies, it refers to any measure that indicates where most values in a data set fall. So basically it's what does the center of the data look like? And we have actually 3 measures that you should all be very familiar with: the mean, the median, and the mode. Again, this should all be stuff that you've seen probably in grade school. And if not, I'll explain it here again. The mean is normally referred to as the average. It doesn't matter, it's just an interchangeable word. So if you're not familiar with how to find the mean, add up the data values and then divide by the number of data values. That's it, that's the mean. The median is simply the middle number. Median's the middle number. You list all the values in ascending order from smallest to largest. And then you find what the center value is if you have an odd number. So if you have an odd amount of data values, it's just the middle number. And if you have an even amount, then you'll have 2 middle numbers. So then you have to find the average of the 2 numbers. Add up the 2 middle numbers together and divide by 2. And then the mode is the one that occurs the most frequently. So again, this should be familiar stuff, and I'll do some problems just to maybe jog your memory of how we go about determining these measures of central tendency. So with example 1, we'll go ahead and find the mean, median, and mode for this given data set. Now notice the first thing I ask for is let's put the values in ascending order. This will really help, not really with the mean so much as it will help with the median momentarily. So just putting them in ascending order, which means smallest number first. So that's a 7 there, 7, 7. So pretty simple stuff. There's an 8. I see a 10, some 11s, and a 22. So that's everything in ascending order. And that'll help with the median when we get there. For now, we'll go ahead and compute the mean. So the mean, you add up all the values, divide by the number of values. The mean is 7 plus 7 plus 7 plus 8 plus 10 plus 11 plus 11 plus 22. So just add all of them up, divide by how many total numbers there are. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 values in total. So let's just do that right fast, see what we get. 7 plus 7 plus 7 plus 8 plus 10 plus 11 plus 11 plus 22. Notice I'm using parentheses because the numerator needs to stay together, and we need to tell the calculator that this is the numerator. So we need parentheses for that, if you want to do it in your calculator all at once. Then I close the parenthesis for the end of the numerator, and then divide by 8. Or however you do it, you should get the same number I get. So we get 10.375. It's that a nice concrete number, no rounding of any kind. So that's the mean. Now we move on to the median. So the median, we need to find the middle number if there's an odd number of values, or the middle numbers if we have an even number of values. So we have an even number of values. There's 8 numbers in total. So we need to find the middle 2. There's going to be 2 middle ones. And so we can go from the outside in. There's 7 and 22, 7 and 11, 7 and 11. That leaves 8 and 10 as the middle ones. So this will be middle values, plural. That's, of course, not the median. We need to find the average of the middle values to get one explicit median. And how do we find the average between 2 values? And the median itself. We need to add those middle values that we got and divide by 2. That's the average. And we're dividing by 2 because there's 2 values. 8 plus 10 is 18, divided by 2 is 9. So that's the mean and the median. And finally, the mode is just the value that occurs the most frequently. I think we can all see here, that's just 7. The mode is 7. So hopefully this is pretty familiar stuff so far. And if not, this is the process for doing so, finding the mean, median, and mode. So any questions up to this point? So whenever the final, I guess the final exam rolls around, this won't really be the case for the assessment. This type of material will be on the final exam, and they could ask you, since you'll be writing scratch work, they may ask you to do all of this by hand. I already did foreshadow that we will be putting this stuff in the calculator. I'll show you how to do that later. But you might be required to show this by hand. So just keep in mind that this is a process that you might want to be aware of, especially when the final exam time comes around. But let's go ahead and do another one by hand, and then I'll show everybody the easy way, the calculator. So example 2, they give us a table of values, and we want to figure out the measures of central tendency for this data set. And so what they're asking for, put the values in, well, what I'm asking you all to do, which I would recommend if you're doing this by hand, is put the values in ascending order first. And I believe that it's almost completely in ascending order. We just need to switch 2 of these. Because as you can see, it's slowly increasing as we go down, but right at the end, there's 2 values that put this not in ascending order. So 1069, 1184, 1200, 1223. Oops, 1255. Another 1255, since we want to put this in ascending order. And then there's the 1307. So those are the values in ascending order. And again, one of the interesting things about this problem, we're not finding the mean, median, and mode for the years. We're not finding them for the years. The years are just labels that tell us the data that we are really looking at and wanting to figure out. We're not figuring it out for the years. We're figuring it out for what they label the awards and dollars. And also, what's indicative of this, we're finding the mean, median, and mode on federal student financial assistance. So it's not asking for the measures of central tendency on the years, but on the financial assistance or the money. So something else that's indicative of using that particular data set. But with all of that aside, we can figure out the mean, median, and mode. Now the ascending order doesn't matter when finding the mean. The mean is just adding all the values together and then dividing by the total number of values we have in our data set. So then we can divide all of this by 1, 2, 3, 4, 5, 6, 7. Did someone already figure out this answer? What you got?
1,213.
1,213.
With 28, but I think you round up, right?
Nearest cent. We'll do to the nearest cent. So you said 28?
Yeah.
Did anyone else also get that answer? Did anyone else? I'm going to assume this is good, just for the sake of time. If not, just quickly let me know and we can verify it together. I'm going to assume that's correct though. And the median, well, this is based off of whether we have an even number of values or an odd number of values. Well, luckily for us, we have an odd number of values. We only have 7. So we have an odd number of values, which is 7. So that means the median is just one number. We don't have to do anything other than find it. So 1069, 1307, that. And our middle number is 1,223. So that is our median. The mode is the most frequently occurring one. Well, I see it as, hopefully we all see it as 1,255. There's the mean, there's the median, there's the mode. And what's interesting about this is that we have 3 different measures for central tendency, and they all gave us a different value, which is pretty interesting considering you would want those values, if they all measure central tendency, wouldn't you want all those values to be fairly close to each other? Well, some of these values, so if you take stats next semester, we go into this in more detail, but ultimately, these are all measures of central tendency, but one of these might be better to use than others in particular circumstances. And we'll talk about that momentarily. You might see the key word down at the bottom of the screen here. That'll help us really determine which measure might be better than another one in a certain situation. But before I do continue, does anyone have any questions before we move on? If not, you might find yourself really enjoying this section if you are familiar with mean, median, and mode. So let's look at the outlier. Now, an outlier, you might know this word from an intuitive sense. Really, we refer to an outlier. It's some generic term that refers to something that's out of place. But in the context of this class, the out of place aspect of this, it's a data value that differs greatly from the majority of the other data values. So the example I always like to give is if we found the average income of all the students at Southeastern, I mean, some of you might not even have any income, but it wouldn't be very, on average, the average income of every student would not be very large. An outlier of this would be Bill Gates' income. That income is definitely greater than, well, all of our incomes, and that would be considered an outlier. It's a very extreme out of place value relative to the majority of the data. That's what an outlier refers to in this class, in this situation. So it goes on to say something else that's very useful to know. Outliers can bias the mean. The mean takes every value into consideration. It doesn't know whether you have an outlier or not. So the mean could get really biased whenever you implement an outlier. In this case, the median might better suffice. This is an important idea. If you have outliers, you should not trust the mean. So, for example, in my statistics class that I teach this semester, the mean for the class was, I believe, a 67, 68, and the median for the class was a 76, 77. Why is that so different? It turns out, for one of my classes, 4 people didn't even take the test. They didn't show up. Well, those 4 grades, those 4 zeros were outliers. They all affected the average, but the median wasn't really affected that much because the median doesn't care about what values are there. It just cares about how many values you have. So that's why I trust the median as being the best representation for how my class did as a whole, rather than the 4 students who did not take the test. So that's just some application, and that idea will come up. In fact, it comes up in example 3 here. They give us a data set, and they ask us which single measure of central tendency, the mean, median, or mode, best describes the center of this data. Does anyone have any intuition? What would be the best description for the center of this data? Yes, it would be the median. And why is it the median?
Because it says something about the middle.
Well, out of these values in this data set, is there anything fishy about one of these values?
Outlier.
Well, check this value out. That's an 85. The rest of these values are lower than 10. And then here we have an 85. This is an outlier. This is an extreme value that's much different than the majority of the values in the data set. That is considered an outlier. And what do outliers tell us? Outliers ruin the mean. Because now the mean is going to think that that outlier value is just, oh, it's supposed to be in there. It's a completely normal value. Outliers ruin the mean. Thus, we use the median. And normally we never use mode. Mode is used when we have discrete values, but in this class, we don't even define discrete. So really, we only care about mean or median. Mode is never really a good indication of this, unless we're just counting the occurrences of something. But again, we use the mean if there's no outliers. We use the median if there are outliers. Simple as that. Just simple as that. Okay, so are there any questions up to this point? Okay, so now let's move to how to do all of this in the calculator. So the precious calculator to tell us how to do all of this without barely having to move a muscle. So if you ever at any point forget how to do this process in the calculator, I think my notes are very explicit on how to do so. And I'll follow along as well. And this should be the same on everybody's calculator, with the exception of one little part that shouldn't be too big of a deal. Okay, so I gave a data set here. So just a bunch of numbers, something for us to try out. It just so happens that they're organized. This process does not require the values to be arranged in any order. It will figure it out whether the numbers are jumbled up or otherwise. So we're going to click on the stats button. We get to use the stat button for the first time, which is in the third column, second button. When you click on the stat button, you should see exactly this. We can edit in here. So press enter on edit, and it brings us this collection of L1, L2, L3. So what we're going to do, we're going to stick with L1 throughout this class. We're going to stick with L1, and in L1, it allows us to put in a data set. So I'm going to put in each number followed by enter, so I can input the data here. There's 112, and I'm just going to keep doing it for every value. I'll go ahead and do that very fast. I'll give you all a second to catch up there. And once you're done, you should have 12 values inputted. It also says L1 13 down here, which means the 13th slot is blank. So the 12th slot, that's another way to check that you typed in 12. Some people will, well, this is data entry. And with data entry, there's always room for human error. So you always want to check and make sure, which I will ask you all if you have the same answer I got, because I will commonly type in something wrong. It's very natural for human error to occur in data entry. Okay, so we typed each value into L1. We followed it by enter until all the values were added. Now we're going to press second in mode. So second and just immediately to the right, it says mode, but above it, it says quit. So that brings us back to the main screen. So everything's already stored. We're going to come back to that. We're going to press second and quit to come back to the main screen. And once we're back to the main screen, we're going to click on stat again. So you're going to see all of this yet again. The only difference is now we have L1 populated with our data values. But instead of clicking on edit again, we're going to move the cursor over once to the right to highlight calc. So this is to calculate certain, it does some statistical analysis. And there's a whole bunch of options here. The only one we're going to use in this class is the one var stats, which I'm going to press enter on. Now, if you have one of the lesser calculators, you're going to see this. If you have one of the fancier calculators, you will see list and FREQ list. There should be nothing next to FREQ list. Is that for the fancier calculator people? Do you have anything next to frequency list? If not, that's good. That's how it should be. And just keep pressing enter So in my case, I only have to press enter once. For the fancier calculator people, you might have to press it a few times until you get exactly what I have on the screen. If you got those numbers I got, then you did everything correctly. So the best indication is the first number. If you got 20.5 for the first number, you did everything correctly. So I'm going to be on the assumption that everyone is up to this point now. And I'm doing another problem like this in case you might have missed it. So now what we have, and if you move your cursor up and down, you will see all of these different values. And we're actually going to be using almost the majority of these values in this chapter. But for right now, we're only concerned with two values. And I do explain what each one of the values mean, what each one means in the notes here. What we care about is the first one, the mean, which is x with a little bar on top, and the median, which is appropriately titled MED. Those are the two we care about for now, because of course that's the mean and the median. Those are two measures of central tendency. So remember, this was an example that we did, and so now at the very bottom, therefore the mean is 20.5. Remember, that's referring to the top number, the x with the little bar on top. In the median, we scroll down on our calculator a little bit, we see that the median is, just so happens to be the same number, which is a coincidence, by the way. It doesn't happen in general, but we did get the same number. Again, that's not always going to be the case, as we'll see later on. Does anyone have any questions before we look at another problem? If not, let's go ahead and do exactly that. So we'll just do a whole different problem. Same idea though, and we'll throw the mode in as well. So whatever the wording says for the context, it doesn't matter. We have a data set. And they want us to find the mean, median, and mode. So I'm going to go straight to the calculator and put this in. So you could press clear to get rid of the old results. So I'm going to press clear. And then we start over. See how well we remember the steps now. And click on stat. And now we're going to edit because we actually have to edit the numbers in. You might think, but there's all these numbers here from last time. So I want everyone to pay attention right fast. This is going to help you out later. Move your cursor upwards to where L1 is highlighted. So notice how the cursor is now on L1. Don't press delete. Don't press that button. Press clear. Press clear and enter, and it will clear it for you. I get that question asked a lot. So move your cursor up to the name of the list, and you press clear and enter, and it will clear the list for you. We want to stay in L1. You don't want to move over to L2 or L3, or you're going to confuse, well, I say confuse the calculator. You would have to do more work on your end to figure out how to implement that. We're going to stick with L1 though. And from here, we can go ahead and type in each value. Again, it doesn't have to be in order. You type it in any order. So here I'm not putting this in ascending order. It doesn't matter. By this point, yes.
If you do just a wheel L1 and it disappeared,
L1 disappeared?
yeah, do I have to reset my calculator?
Yeah, you probably have to reset it. I can figure out. Reset. Reset. Okay. Okay, cool. So from this point, you have everything typed in. Remember, the next thing you do quit out of it by pressing second and mode, just right next to it, second and mode, which will evoke the quit command. We go back to stat. We move our cursor one time to CALC, and we use one variable stats. Enter, just keep pressing enter, regardless of which calculator you have, keep pressing enter till you get hopefully these numbers. And who else got these numbers? You got it, you got it. So I'm going to trust that I typed it in correctly by the power of majority. If you did not, then definitely try it again and make sure you get these numbers. But if you did, it seems like you did everything correctly. So the mean is always x bar, which is the top number, 0.185. The median is MED, which all you have to do is go down on your calculator. And so notice it's a different number, which is fine. In fact, that's pretty common. 0.165 for the median. But what about the mode? It doesn't really give the mode, does it? Well, we can just figure out the mode ourselves. That's a pretty easy one that we can figure out ourselves. I see that 0.15 pops up more frequently than the rest of them. I think the rest of them pop up. I don't even think, okay, one of them pops up twice. So for the mode, I see 0.15. The calculator doesn't tell you that one. So you could just quickly figure that one out on your own. That's the most frequent one. Okay, how does everyone feel up to this point? Okay, so let's move on to example 6, which almost seems like the same problem, but it's going to have us modify things a little bit here and there. So we have this table that gives the total area in square miles, and we're going to complete these following parts here. So they give us ultimately a table of values. Now, don't be misled. We are only computing, or rather our data set is this column. Because it says find the mean area and median area for the 7 states. So we're only looking at area. The state, those numbers are just labels on the left. So don't throw those into your computations as well. So first, as I said, it just wants the mean and median. So find the mean and median. So I'm going to go right back to the calculator, do everything we just did again. So this part should not be too complex. On stat, edit, we can clear out the values by going up to L1 and pressing clear, not delete, but clear, enter. If you press delete, it's going to make L1 disappear and you'll have to reset your calculator. 52500, and I just start typing in all the values. 5100, 114300, 53200, 59200, 104, 100, and 6000. So you should have 7 values typed in, which is indicated by the calculator saying L1 of 8, meaning that the next space that it's waiting for is 8 to imply that you've typed in 7 of these. Once you typed in everything, we can quit out, second in mode, back to stat, move over to one variable statistics and just keep pressing enter until stuff comes up. Of course, I'm gonna keep asking, did anyone else get these numbers as well? You got it? Yeah, so. If you did not get these numbers, a lot of times what happens, I see a lot of people might forget a 0. You might miss a digit. You might have missed a number. You might have added an extra number. It happens all the time. It's human error. You just need to make sure you second you double check yourself. So provided you typed in everything correctly and we all got these values, we can see that the mean is the top number, 15771. And I'm just going to round it as a whole number for no particular reason. It might ask for 2 decimal places. I can't really remember. So I'll just leave it at that. You can add decimals if you'd like. It's whatever MyMathLab says. And then we can scroll down to see what the median is. Oh, there's no rounding involved here. 104,100. Okay, so I think that part should be straightforward. Just type it in the calculator, see what we get. Part B says, which one of these values is an outlier on the high end? As in, which one is excessively larger than the other values? Well, if anything, I think it's this one. These values, well, the majority of the values go up really to 160,000. Then here's Texas over here being way more than that, or some state, some large state. So we found the outlier. If you eliminate the state, what are the new median and mean and median areas? So it's saying, let's do all of this again, but eliminate the outlier. So that's what it's saying. We're eliminating that outlier. Okay, so we just do everything again, but we get rid of the outlier. So clear out of the old results, click on Stat, click on Edit, and instead of typing everything in again, the one we just deleted was the, we just deleted the 615,000. So I'm going to put my cursor over the one we want to delete, and I'm going to press the delete button. The actual delete button, not the clear button, but the delete button. Now that entry is completely gone. And guess what? All the rest of them just kind of shift up into place. So that's it. There's our data set. Notice I used delete for that, not clear. So we have that. We can quit out, go back in, determine the one variable statistics, and we get brand new numbers. So I guess I forgot to put that state 2 was the outlier. And we can jot down the mean and the median. The new mean is 81,550. The new median looks like my calculator froze up. Interesting. I don't know how to fix that. 1 second. Okay, cool. And the new median is 78,650. Okay, so there's the mean, there's the median when we got rid of the outlier, which is normally what statisticians do. They'll take the outlier, if there are any, either get rid of them or water them down to where they're not as impactful on the majority of the data. Okay, so we did that. So now it says, which one of these 7 states is an outlier on the low end? Which one is just abnormally small? Well, this is on the implication that out of these 7 states, so that's implying we're bringing the 6,000 or the 615,100 back in. And so now out of all these 7 states, which one's the outlier on the low end? Well, the 6,000. The 6,000 is significantly smaller than the rest of these values. And so it wants us to, again, figure out the mean and the median for the remaining 6. So we are bringing back the 615,000. So state 7 is the outlier on the low end. And let's scroll up to put this into the calculator. We're going to go to edit. Well, really, in the place of 6,000, I could just put 615,100. Because the order in which you put them in the calculator doesn't matter. It's going to arrange all of them behind the scenes anyways. So as long as you have those remaining 6 values, however you do it, let's all see if we get the same answer. Stat on variable statistics, and we get new numbers after we got rid of the outlier on the low end. And we get a new mean of 183,060, I'll call it 67, just round to the nearest whole number. And then for the median, you get 109,200. And it should make sense that getting rid of a significantly smaller number makes the mean and the median skyrocket. Because that super small outlier was giving a much smaller estimate of the central tendency or the central measure for the data set. So that looks like that concludes this problem. Does anyone have any questions before we look at another problem? Okay, let's look at the next one. So there's a warehouse that employs a supervisor at $1,100 a week, inventory manager at $830 a week, a few stock boys, 6 of them to be exact, at $450 a week, and 4 drivers at $500 a week. So with all of those values, they're wanting at first the mean and the median. So that means let's go straight to the calculator. Now, let's be careful about how we put this in the calculator. Because when I go to the calculator, if anything, I'm going to clear out the old values, move my cursor up to the name of the list, and press clear, enter. It clears everything for me, very convenient. So there's a supervisor at 1,100. All right, so far so good. An inventory manager at $830 a week. And then there's 450 for the 6 stock boys. Now the problem here, this is being applied for 6 people. There's 6 people involved here. So before it was just 1 supervisor, so 1 occurrence of 11,000. There was 1 inventory manager, but now 6 stock boys. So I have to put 450 6 times. I've seen this mistake quite a few times over the semesters. We have to put 450 6 times because there's 6 people making this amount of money. That's 1, 2, 3, 4, 5, 6. So you have to put 450 6 times. And then the 4 drivers at 500 per week. Well, that means we have to put 500 4 times. Each one of the 4 drivers. But you should have 12 values in total, not 4, because some of these are counted more than once, because more than one person is making that amount of money per week. So that's why I put 450 6 times, and I put 500 4 times. But once you hash out those details, then we can figure out the mean and the median real quickly. So we can quit out of that, stat, 1 variable statistics, and let's figure out the mean and the median. It looks like this is $552.50. I'll add the extra 0 because this is money. And the median $475, just even. So hopefully so far so good. Now, how many employees earn more than the mean wage? Well, the mean wage, what was the mean wage? That was $552.50. How many people earn more than $550? Well, we have the supervisor, they earn $1,100. Inventory manager, that's $830. And so that would be it. It is in fact 2. So 2 employees. The supervisor and the inventory manager. Everybody else makes less than that. And now a question I want to ask you all. Which measure of central tendency, or best measure of center, as it's called in this class, either the mean or the median, best describes a typical wage at this company? What do you all think? Mean or the median? Why do you say the median?
Because it's more than 500.
So you're saying, so you said more than 500?
Or actually, it's probably the median because you have 6 doctors.
You're getting closer. You're getting closer. Something about, all right, 6 stock boys. Okay, well, what is the toss up between the mean versus the median? Remember what we mentioned earlier? Outliers. Do we have any outliers in this problem? Yes, the 1100 is an outlier. So, yeah, so it all comes down to, is there an outlier? And there is an outlier, the 1100. There is an outlier. Because of course the main guy is going to make significantly more money than than the lackey stock boys and drivers. It's going to have himself a lot more money. So there is an outlier, which means we use the median. That's why we use the median. Is because there's an outlier. That's it. So basically, this is the refined understanding that comes from the intuition that I was hearing. It ultimately comes down to not that there's typical values over here, but the fact that there's an atypical value over there, which makes us think, well, the mean is going to be a biased value, and we need to look at the median. Which does make sense because the median is right smack in between the majority of the workers. There's the 450, and there's the 500. 475 is right smack in the middle. The mean is a little bit larger. Doesn't split up the data as much. Okay, any questions before we move on to the weighted mean? If not, we're going to move on to example 8, which is a little bit different because this is something called the weighted mean. And what I mean by that is not only do they give a number of victims, but they give the frequencies as well. So basically, how many zeros are there? How many ones are there? How many twos are there? And so this is going to result in something called the weighted mean. So basically, you're not going to find the average of 0 plus 1 plus 2 plus 3 plus 4 more, which they call 4.5. because 0 doesn't just occur once. 0, if you wanted to do this by hand, you would have to do 0 plus 0 plus 0 plus 0. You'd have to do that almost 4,000 times. It doesn't sound very practical. So that's why we need to find a weighted mean, a way to condense this process to where, of course, we don't have to write out 0 almost 4,000 times and write out 1 another 263 times. So to find the mean, and the same thing in the calculator, you would have to put 0 in the calculator about 4,000 times. You'd have to put 1 in the calculator about 263 times. And again, that's not practical either. So we can't even use the calculator. That's why we have to use, technically there's a calculator way, but all of my stats students can never seem to remember it. And I thought, all right, well, I'm not going to have you all remember it either. It's not bad by hand by any means. So instead, let's think about what happens if we add 0 to itself. If we add 0 to itself 3,947 times. Now you might say that's still 0, which you're correct, but we can write this in a more compact form using just 2 numbers and a multiplication symbol. This is the same thing as 0 times 3,947. Which is still 0, of course, but it does give us this intuition towards the fact that instead of writing 0, adding it to itself almost 4,000 times, we can say 0 times 3,947 and then add that to, well, we can do the same thing with the 1s. And we have 1 plus 1, oops. Let's think about this one. 1 plus 1 plus 1 plus, we do that, apparently we do that 263 times. So instead we can write that as 1 times 263, instead of adding 1 to itself 263 times. So 1 times 263, and then plus, well, the next one is 2. We would add that to itself 98 times, or multiply by 98. Plus 3 times 42. Plus, well, 4 or more. How do we represent that? Well, it says use 4.5. It says 4 or more, just use 4.5 in that case. They're just telling us to do that for no real reason. I guess to make sure these are not misconstrued as decimals, I'll put multiplication. There you go. Times. And this one's 26. So this is us writing in a lot more compact manner all of these additions that we would be doing. So again, you cannot do this in the calculator unless you did the trick that I show you, which I don't want to show that for this class because everyone's going to forget it. And then we have to divide that by the total number, which they actually give us as 4,376. They gave us that for free, 4,376. So we can do all of this in the calculator, and we can see what we get. Okay, so no stat is required here. We're doing everything just by hand. I'm putting the numerator in parentheses to do this all at once. 7, which that's obviously going to be 0. 1 times 263 plus 2 times 98 plus 3 times 42 plus 4.5 times 26. Close the parentheses because we're done with the numerator. Then we can divide by the denominator, 4,376. And we'll round this to, let's see, maybe 3 decimal places. 160. Round it to 3 decimal places. They might ask for 2, they might ask for 4. But that would be the mean. And notice the weighted part is the fact that we multiplied the number by the frequencies. That's the weighted part of this. Do that. Technically, we could have also done this for the previous problem. We multiplied the 450 by 6 and multiply the 500 by 4. Could have done that in the previous problem as well. But this one had way too many frequencies. Just the frequency was too high. Wouldn't be able to put it in the calculator. Okay. Now it says find the median. Well, the median, again, we don't have a calculator to really help us here. So the median is going to be, of course, the middle value. Does anyone happen to see what the median is? Just by looking at this.
Is it 2?
Not going to be 2, because we're not listing out 0, 1, 2, 3, 4, I guess 0.5. What we're doing is we're listing out 0, 0, 0, 0, 0. We're doing that a bunch of times, 3,947 times to be exact. And then after you're done with that, then you would list out ones a bunch of times. Now, if you were to do all of this and you kept going and then you got to the 4.5s that you would have to write down 26 times, what do you think the middle value would be? What is the dominant value in this problem? What appears the most?
0.
It's 0. 0 is the median because there's so many zeros that the numbers after the 0 are just meaningless. There's just not nearly as many of them. There's just too many zeros. So if you wrote out all of those values, then you would see that 0 is clearly the middle. There's just way too many zeros. Now it's saying if 17,000 or 1,747 of these shifted from 0 to 4, so if we took off 1,747 and then added that to the final category, how do the mean and the median change? Well, as we already found out, well, I'll start with the mean. As we already found out, the mean will change because the mean is very sensitive to changes in values. In fact, in stats, we call this not resistant. The mean's going to change because the mean takes every value into consideration. So if we just transition 1,700 of these to a whole different category, the mean is going to change drastically. And you could technically do the computations for this, but it's not asking for the new computations. It's just asking conceptually, how do the mean and median change? The median only cares about the number of values. And if you do work out these computations, you would see that there's still an exceeding number of zeros, even if you add 26 plus 1,747 for that last quantity. So in other words, the median's pretty stubborn. It takes a lot more to affect the median. So it will stay the same because there will still be an excessive number of zeros. More than half of the frequencies involved come from the zeros, which means it will dominate the middle value or values. Does anyone have any questions up to this point? Okay, let's keep going. There's another weighted mean problem, one that's, I think, a lot more simplistic. It's about calculating your grade. So this is something that actually my math lab uses, a formula that we're about to use that my math lab uses to figure out what your grade is in the class. Because as you know, not every grade in this class is weighted the same. A workbook assignment versus the midterm, you may get 100%, or let's just say you might get a 70% on the workbook and a 70% on the midterm, but those grades aren't going to affect your grade the same way. And the reason why they're different is the weights are different. One of these weighs more than the other. So to determine this, well, it says that in this situation, the midterm is 15% of your grade. This class project is 25%. Homework is 50%. And the final is 10%. So they give us 4 different categories of grades here. And then they go ahead and tell us what the grades were out of 100. So the midterm was 15%. And then they go on to say, well, this person scored a 71 on their midterm. So if they scored a 71 on their midterm, and that was 15% of their grade, we're going to convert the 15% to a 0.15. And so that's the midterm right there. I'm going to add that to the next category, the class project. The class project was 25% of their grade, and the project score was an 89. So we had an 89 for the project score that weighed 25% of their grade. Next is the homework. Homework's 50%. And they got, for the homework, a 78. So they got a 78 for the homework. And that was 50% of their grade, or 0.5. And then finally, the final exam, 10%. They got a 67 on the final. And so we don't need to divide by anything here because technically the division already happened when we converted the percentages to decimals. We could have left those as whole numbers and divided by 100, which would not be the total number of categories, but the total number of points. But technically we already did that. But this would be the weighted mean with the division already included. And so all we have to do is throw this into the calculator. (71 times 0.15 plus 89 times 0.25 plus 78 times 0.5 plus 67 times 0.5. We get 78.6. And so that would be the final grade for this person. Again, this is a formula that my math lab uses. Figures out your grade in every category, figures out the weights, and then performs this weighted mean algorithm to compute whatever your grade is in the class. I use a very similar formula when I send out to everybody what grade you need to make on the final to make a certain grade in the class. I use a formula very similar to this. I just simplify it a lot more. Does anyone have any questions up to this point? If not, let's move on to the 5-number summary. Now, the 5-number summary is a different way of looking at not just really the, well, the 5-number summary is based off of the median. The 5-number summary does not really deal with the mean at all. It deals with the median and also these values around the median. which represent proportions. How many values lie within a certain interval? And this 5-number summary gives us a pretty good approximation of how to make this determination. So 5-number summary, as you would imagine, there's 5 numbers involved. There's the smallest value in the data set. There's the first quartile. There's the median. There's the third quartile, which is the upper quartile. And then there's the largest number in the data set. The smallest number, this thing called the first quartile, which we'll get to later. The median, which we know. The third quartile, again, save that for later. And the max value. This comprises the 5-number summary. From here, I went ahead and also threw on these formulas. The inner quartile range, which is the difference between the quartiles. And then there's these things called fences, which I'm going to go ahead and provide their formulas here. Now the inner quartile range, that helps us find these fences. And what the fences are helpful for is fences help us find outliers. Think about it as an actual fence. Everything outside of the fence is considered unusual, an outlier. Value less than the lower fence, greater than the upper fence. So that's just a bunch of information I'm throwing your way. But what we're going to start looking at is what this 5-number summary tells us before we look at this range and these fences and everything like that. The 5-number summary tells us that approximately 25% of data values lie within each adjacent number in the 5-number summary. So the smallest data value in the first quartile, those numbers are adjacent in the 5-number summary, and 25% of data lie in between them. What about between the third quartile and the largest data value? 25% lie in between them. What about the first and the third quartile? What percentage of data lies in between them? 25 and another 25 to give you 50. Each time you go in any direction in the 5-number summary, you will go in increments of 25%. This also makes sense because quartile has a prefix, QUAR, which means 4. And this is referring to fourths, which is 25%. So that's another indication. Quartiles split things up into fourths, which is 25%. So this will be the first thing that we look at as we explore example 10 here. In example 10, they give us the 5-number summary. They tell us the smallest value, the first quartile, the median, third quartile, and the max. They tell us what this 5-number summary is. Probably next time in class, we'll compute how to find these. But if we have them already, let's just figure out how to interpret it. So to figure out the percentage of states in this question that have cigarette taxes greater than 40 cents. Now what this is saying, so greater than 40 cents, well, we need to find where 40 cents is at. Well, Q1 is 40. So in fact, the chart that I have at the top, the minimum's 9, Q1 is 40. I'll use a chart like that because that'll be pretty helpful. And what's next? 72, 104, 135. So we are at 40, so that tells us where we are at relative to the other numbers. And we need to figure out the percentage that's greater than this value. How do we go greater? Jump. But we could still keep going, jump again, still keep going, we jump again. Until we're out of spaces to jump. So how many 25s did we accumulate? 1, 2, 3, which that's 75%. So 75%. So that's what we found so far. So each time we step, that's accumulating 25% of the data. So let's start over and look at part B. Greater than 104 cents. That's the third quartile, which is right up here. We're looking for everything greater than 104. So greater than means we go to the right, but we only can step one time because there's no more numbers to step to. So how many 25% did we get? Just one. That's it, 25%. So then it talks about the lower bound of the middle 50%. So the lower bound and ultimately the upper bound for the middle 50%. The middle 50% of data is characterized by the first and the third quartile. Middle 50% is bounded by Q1 and Q3. So that's just a fact. So basically what it's asking for is what's the first quartile and what's the third quartile, which all we have to do is look up. They gave us those already. First quartile was 40, third quartile was 104. So that's all they're asking for. Basically, do you know the definition or do you know this fact? Okay, we can also figure out something called the interquartile range. Well, inter in INTER sense means in between quartiles. So it's in between the quartiles, and the range means the difference between. It's the difference between the quartiles. If you need a way to memorize the formula. IQR is equal to Q3 minus Q1. Simple as that. It's 104 minus 40. And that's 64. So that's it, 64. Finally, it wants us to determine if we think the distribution is bell-shaped. What this is a fancy way of asking us to do is the median minus Q1 about the same as Q3 minus the median? That's what it wants us to find out. So the median was given to us at the very top, that's 72 minus 40. Is that equivalent to Q3, which is 104, minus the median, which is 72? So that's what we're asking. That's what we want to find out. That's 32. Is that equivalent to 32? Well, that seems to answer it. Yes, they're exactly the same. So this is bell-shaped. And that's it. Besides for that, I guess this is a good place to stop. Remember that the homework for probability is due tonight and the quiz is due tomorrow. The workbook is due Friday. So, yeah, all those due dates were in the email I sent out already. But besides for that, please get the homework done tonight if you haven't done so already. See you all next week. Have a good day.